so now that we've seen one of the reaction writing processes together, I would like you guys to try one on your own. So please write out the chemical equation, the balanced chemical equation for the combustion of propane. This propane is going to combust in the presence of oxygen gas and will create some gaseous carbon dioxide and water. So what is the balanced chemical equation for this reaction? All right, so our combustion reaction of propane is going to take the form of our hydrocarbon, C3H8, combining with a certain number of oxygen gas atoms. Our oxygen gases are always going to come in the form of O2. This is going to turn into a certain number of carbon dioxides, as well as a certain number of waters. And we can add the phases afterwards if we want. I admittedly was just a little too lazy to do it right here, since the focus is on balancing our chemical equation. Now let's balance this chemical equation by adding the appropriate number of stoichiometric coefficients. We're going to go the long way first and then compare this, our end result, to the previously stated generic form for a balanced combustion reaction. So numbers of carbons, numbers of hydrogens, numbers of oxygens. We're going to have, or we can see, a total of 3 carbons, 8 hydrogens, no oxygens underneath our C3H8, 0 carbons, 0 hydrogens, and 2 oxygens underneath the O2, 1 carbon and 2 oxygens underneath the CO2, and 2 hydrogens, 1 oxygen underneath the water. So a really good practice when balancing a combustion reaction, especially as a way to not have to memorize any specific forms, is to start with your carbon. So if we start with our carbon first, move on to our hydrogen second, the main motivation for doing this, for starting with carbon, moving on to hydrogen, and then doing oxygen last, no matter the form of your combustion reaction, is we can see that the carbon and the hydrogen are both in only one molecule on the reactant side and the product side. Like carbon starts in one molecule and ends in one molecule. Similarly, hydrogen starts in one and ends in one. The oxygen, starts in one and ends in 2 different places. So this can make oxygen a little bit tricky to balance, and so we're gonna save it for last. All right, so let's start with our carbon first. We can see that there are 3 carbons on the left, only 1 on the right. So let's scale this up, giving us 3 carbons and now a total of 6 oxygens underneath carbon dioxide. Then if we move on to hydrogen next, we can see we're starting with 8 and ending with only 2. So we're gonna have to scale this up by a factor of 4, giving us 8 hydrogens and 4 oxygens underneath the water. Now this is again why we save the oxygen for last. The carbons and the hydrogens now are perfectly balanced, and so the equation can look complicated, but if we start with carbon and hydrogen first, we can save ourselves a little bit of time, because now at the end we can see that we have 2 oxygens on the left and a total of 10 on the right. Since we saved this for last, we can now add a 5 in front of our oxygen. This 5 being placed in front of our oxygen will scale up all of those on the reactant side also to equal 10, giving us a nice, totally balanced chemical equation.